Alright, here we get to talk about cones. So there's a couple things that I want to point out about these equations that are a little bit subtle. The first thing, the height goes straight from the vertex at the peak, straight down perpendicular to the radius. That's the normal straight up and down height. This, down the slope side, is the slant height. We're going to abbreviate that as L. So the slant height is going to be used to find the surface area or lateral area, whereas the straight up and down height is used to find the volume. And you can see that there is a right triangle built into every cone, as long as it's a right cone, which means that the vertex is standing directly above the center of the circle, which is that's all we're going to deal with for now. There is always a right triangle built into that, where the hypotenuse of that right triangle is that slant height. So if we're given the slant height, it's not directly useful for the volume, but you can use that and the radius to work backwards to solve for the height, and vice versa. If you have these two, the radius and the height, you can use that to solve for the slant height, and then plug in to solve for the surface area or the lateral area, which is going around the outside of that shape, not including the base. Really, we're just missing the circle from the bottom. All right, so on this first example, we are looking for the surface area of that figure or cone. So I'm looking at pi r squared for the base, and then pi rl for the lateral area going around the outside. So I'm going to use the radius. This, even though that arrow is actually pointing, it looks like it's pointing at maybe just that side, I think it's indicating the entire diameter. So that's our diameter. We're going to use 4 as a radius. And the slant height we actually don't have right now. We don't have that slope side, but we do have a right triangle that can help us find it. This side is going to be 4, that's 9. We're going to use Pythagorean theorem to find that missing side. So we're going to do 9 squared plus 4 squared, and that's going to equal our c squared. The slant height is always going to be the c in that right triangle. So that's 81 plus 16, or 97. So C there is 9.85. I'm going to just round that 9.85. So that's the slant height of that cone. That's what we're going to use to actually find the surface area there. There's times where you'll see your answers written in terms of pi. So you might write this as 16 pi plus this is 39.4 pi, and you're really just going to combine like terms there and get 55.4 pi, and you might actually just see your answer written like that, or you might actually see that multiplied out to get the decimal 173. I'm just going to round that to the hundredths place, 0.96. We're talking about surface area, so we're talking about whatever units we have squared. All right, so here we're dealing with a cone that is cut into 3 pieces. Each piece has the same height. We're going to find the volume of the bottom part of the cone pictured here. So I want to make the distinction between this and what we learned in the last lesson, where we just changed one attribute. That's not really what's happening here. We're not shrinking this down to 1/3 of its size. We're cutting off the top 2/3 of this, and the remaining height is at 2.5. So I know the full height of that cone when it was intact was 3 times that size, or 7.5. And the radius is at the bottom there, that's 1.5. The cone that got cut off the top, so I'm going to really just find the volume of this cone and subtract the volume of the cone that got taken away. Oops. Which has to be 5 inches, 5 centimeters, that's the remaining 5 centimeters there. And it has a radius of 1 centimeter. So we're going to find the volume of each of those and then subtract those. That'll leave us with this remaining volume. That's the bottom third portion there. All right, so for the bigger cone, using 1/3 pi r squared, so that's 1.5 for that big cone, times the height, which is 7.5. For the littler cone, 1/3 pi r squared, which is really just 1, times the height, which is 5. So the bigger cone, when we multiply those together, make sure you do your exponent first. That gives us a volume of 17.66. The smaller cone, we multiply those together, and we get 5.23. Subtract those, and the remaining volume is 12.43 centimeters cubed. So it turns out that that's holding about 2/3 of the volume, even though it's only about 1/3 of the height.